Okay, I think we should be good to go. It's a bit past. We had some technical difficulties with the projector and stuff, but I think we're good to go now. So, uh, sorry, what was that?
I think it's using the laptop mic.
Yeah, that was part of the technical difficulties. The YouTube stream is going through the nice mic, and then Discord is on the laptop mic, unfortunately. And now I just shifted my computer and the projector disconnected. Oh, and we're back. Okay. Well, hopefully that doesn't happen again. I won't touch it. We'll see if that does it or not. So, LaTeX. Has anyone here used LaTeX at all? Very cool. Okay. So, LaTeX, in case you didn't know, LaTeX is a typesetting engine. Unfortunately, I can't see my slides up here either, so I'm gonna have to turn around and read them. But LaTeX is a typesetting program for laying out documents, kind of like Microsoft Word or Google Docs. Most people have used those. You kind of have to get through like writing a paper or whatever. Where you got to use something to write and typeset a document. It's most commonly used in academia to write papers due to its ability to easily lay out mathematical equations and create diagrams. So if you've ever used something like Obsidian and Markdown for taking notes, and Markdown has like its math mode, Markdown's math mode is just LaTeX math mode. It just borrows it wholesale. I think it uses some of the same engine components to actually render it, which is pretty neat. But that also means you have a head start on Markdown on LaTeX too if you use that. Unlike most typesetting program, yeah, it is just not my day today, huh? Uh, yeah. Okay, well, unlike most typesetting programs, LaTeX is not a WYSIWYG editor, as folks call it. Uh, WYSIWYG stands for what you see is what you get. So something like Microsoft Word and Google Docs, those are WYSIWYG editors because you see exactly how the document is laid out in the editor. It is a very fun acronym to say, which is why I've been saying it, taking the opportunity to say it. But LaTeX is different from that because documents are actually just plain text files that use a markup language in them to define how the document gets laid out. So instead of clicking the font size button and then increasing the font size, and then clicking the red color button to turn your text red, you have certain control sequences that you put in to say, okay, any text from here on out is going to be red and it's going to be 14 point instead of 12 point, that sort of thing. There. See, I just have to wait it out. I just have to wait it out. If I keep talking, it'll fix itself. And you can do other things like images, tables, lists, all sorts of stuff. Basically, anything you can do with Word and more, you can do with LaTeX. Documents have two main parts: the preamble, which is where configuration and various settings and packages are. So you can pull in different packages that people have written to do things like change the margins or do like code highlights or like syntax highlighting for code, that sort of thing, fancier lists. Uh, and then the body contains the actual content of the document, the stuff that gets rendered. Uh, and it's all contained within the body environment, which the main way you actually get into like these environments and then do stuff in LaTeX is via control sequences. All the control sequences in LaTeX start with a backslash. The control sequences /begin and /end are used for environments. Those are special ones where an environment basically gives new meaning to the like the stuff text inside of it. So like for a bulleted list or an unordered list, you would create an itemized environment, and then you can use like the backslash item to create new bullet points. And actually, the fun thing with this slide is the text on the left. The source code for that is actually on the right here. So this is the code that was used to render the left side of the slide. You can see it gets into an itemized environment using begin. It has some items. You can see the text BF for bold. The fancy LaTeX, like the fancy LaTeX thing, is a built-in macro, which is pretty cool. Uh, yeah. Sorry, what was that? Did the slides die again on Discord?
Yeah, the slides are still locked on the title.
Oh, that's lovely. Let me double check my OBS real quick. There. Thank you for letting me know.
Looks good, thank you.
Okay. So, yeah, fun tangent. The all the LaTeX control sequences have a backslash at the beginning of them, and while doing research for this, the backslash actually has a whole bunch of fun names. It's also known as a hack, a whack, a reverse slash, a slosh, a down whack, a back slant, a back whack, a bash, reverse slant, reverse solidus, and a reversed virgule. And nobody knows where it came from. The backslash just kind of showed up one day in a technical manual for a Morse code teletype in 1939. And that's the earliest anyone's ever, like, we can trace it back, which is kind of funny. Tangent aside, some common patterns for doing all the normal fun stuff in LaTeX that you do in something like Word: bolding text, italicizing text, underlining, changing the font size. LaTex's font size, default font size stuff is a bit different from Word, where Word you set the font point specifically, where a point is a 72nd of an inch. LaTeX just has built-in like backslash large, backslash big, small, and then tiny. There's a few extra macros in there to change the font size. You can, using a package, you do like actual point font size, but it's generally better to use those size macros because those will actually scale with your documents, like default font size. Because a lot of document classes let you set the font size globally at the beginning. And then you don't have to worry about, oh, well, I changed the default font size to 14 points instead of 12. Now everything that was 14 should be 16. It'll all scale automatically, which is pretty cool. Then the mentioned a bit earlier, but itemize and enumerate environments can be combined with item for unordered and ordered lists respectively. So if you want bullet points or you just want like 1, 2, 3, 4, that's what those are for. Some tools here. Overleaf is a online LaTeX editor. It's probably the easiest way to get started writing LaTeX. The basic tier is free, but if you like have a server, you can actually self-host it, which is pretty cool. I have all my stuff on a self-hosted Overleaf instance back at my house. It also has the pretty easy to understand documentation for a lot of common LaTeX packages on their website. So you don't, instead of digging through a PDF from 2009 for a package that is going to let you change like the color of a font in a picture, you sometimes you can. It's a bit easier to look at Overleaf's documentation. They got tons of really nice examples and stuff like that. Let's see. Text Live is a system for easily setting up a working LaTeX system locally. It can also pull packages from CTAN, which is the Comprehensive Text Archive Network, which basically contains every text package ever made. You can actually download a full Text Live distribution. They do it either twice a year or every year. I can't remember which. But each one, like a full Text Live distribution, is like 6 to 8 gigabytes. And it's like every text package ever made. So you're just set for life, basically, at that point. It's more complex to set up than Overleaf, in the sense that you actually have to download and install software instead of just making an account at a website. But it has a lot more, like, it's a lot easier to customize compared to Overleaf, which kind of locks you down into which engines you can use, how you lay out files, because you can't actually access the file system on Overleaf. That's the logo for it. I didn't actually know that was the logo until I looked it up for this presentation. It's kind of a guy running. I think he's got something written on his feet, but I can't tell what. But the big meat and potatoes here, math mode, the thing everybody wants and is excited for. You can access math mode between $ symbols. So any text you put between $2 signs is automatically put into math mode. It changes the font and then it adds certain control sequences, and some control sequences have different behavior. So this little snippet down here is a bit of text from my physics notes when I took physics 2 or 3 years ago. It looks completely incomprehensible here, but that's what it looks like on the page, which is significantly nicer than what I'd be able to finagle up in Word. Of course, Word uses LaTeX for its math stuff under the hood too, or reading my own handwriting because my penmanship hasn't improved since my elementary school stopped giving penmanship lessons in third grade. Uh, so yeah, if any of you guys ever have to read my handwriting, I apologize in advance. But yeah, that looks much nicer than anything I could write out. And once you actually memorize some of these symbols, it gets pretty easy to just kind of type it out on the fly. I remember at one point during actually this physics class, I was actually doing work like solving an equation algebraically by typing out my work as LaTeX. Uh, so once you actually get the hang of it, it's pretty easy to just kind of push it out onto the page. Common symbols. So if you look up here, there's a lot of um, like non-alphanumeric symbols, a bunch of triangles, which is actually just the capital Greek letter delta. Bunch of subscripts, superscripts, fun stuff. Um, so Greek letters are identified by their names. So for delta, it's just backslash delta. You can capitalize them as well. Not all of them, but the more common ones you can capitalize just by making a capital first letter. So for capital delta, you just do capital D delta. Lowercase, you just do lowercase d delta in the escape sequence, which you can see up there. Fractions is just backslash frac, and then the top and then the bottom in the escape or in the control sequence there. For superscripts, you just use a caret. They're a bit, it's a bit goofy when you have more than one character. You got to put them between curly braces. Otherwise, it won't, it'll only take the first character for your superscript. Subscripts are the same way, but it's an underscore instead of a caret. And then normal text, if you don't want it to like italicize it and put it in its weird font, then you can just do backslash text, which I did for the meters per second label there. Diagrams. This is actually really cool because you can put in like actual functions for diagrams like you would in a graphing calculator, and it'll just kind of spit them out onto the page. Uh, and that's through the PGF plots package. There's a few other ones, but PGF plots is the one I've used, and I think it's the easiest. Those are two diagrams also from my physics homework about 3 years ago. Distance over time and whatnot. Here's another fancy one. This one I made just for this presentation, so you guys are special. That's a sine wave. But you can see it's pretty fancy. I do have some better examples of this after the presentation too. Another really nice thing with LaTeX is the bibliography management. Word does have like a bibliography manager, but if you've ever used it, it's kind of goofy to use. It's kind of, half the time you have to figure out how to shoehorn your sources into it because it's like, oh, there's an author slot here, but I have like 4 authors, or like only one guy's name is a proper author and the rest are contributors. It's just goofy. LaTeX has like really good bibliography management. You can, there's multiple packages actually that do it. The easiest of these is called BibLaTeX. You can use the add bib resource control sequence to escape or to like actually include a bibliography file, because with this you put your bibliography file like into a separate file. It's like an actual data structure, which is kind of nice. You can cite the sources just by backslash cite and then the source name. And then the bibliography, you can actually print it out. Like you put it in the page at your like works cited section using backslash print bibliography. There's an example at the bottom here. According to all known laws of aviation, there's no way a bee should be able to fly. That's a quote from Jerry Seinfeld, man of wisdom right there. Here's an example, BibTeX BibLaTeX file for bibliographies. You can see you just toss your information in there, and then it'll automatically put it out into the format you want once you do print bibliography. That's all I've got for the presentation. So, where did my mouse go? There it is. Where did I put my... There I did. So yeah, these are... Oh boy, you really can't see that, huh? See if I zoom in a bit. There we go. This is through Overleaf. So you can see like all these use packages up here. There's some extra math symbols, the multiple columns, fancier tables, and then for images in here. These are actually my physics notes from like that class 2 or 3 years ago. I'm just milking all the homework I got from that class. Like, I mean, it was a great class, but man, is it paying off now? So I bumped the cable. Let's see. I don't know. Did that kill it again? Oh, it killed it up there. Let's see. Did that kill it for the presentation? Yeah, or for the stream? There we go. Okay. I'm sorry we've been having so many problems tonight. This is I mean, this is our first meeting since break, so still kind of figuring out things, getting back into the groove of stuff. So fingers crossed it'll get a bit better here with it tomorrow night. But yeah, you can see this is, oh, that's circular motion. Yeah, those are all the kinematic equations I copied from earlier. But it lays out super nicely. It would lay out nicely if the projector stayed on. Well, technically it's on, just no source. Back? Oh, we're back. Yippee. So I think it's just got it out for me at this point. Like, honestly, I don't even know anymore. What if I stop, if I take a step back? Will it fix it then? I gotta like stare straight ahead and just recite these notes from memory that I haven't looked at in like 3 years. Let's see, what if I wiggle the cable a bit? Oh, that might have made it worse. Well, are we back? I think we might be back. Okay, I'm gonna make sure the stream works here. Okay. I think we're good now. Where did my mouse go? There we go. Okay. So, yeah, this is just a lot of math. You can see some of the fancier fraction stuff in here because the backslash frac is like a front end to tfrac and dfrac, where tfrac is for inline text fractions and dfrac is for like proper big display fractions. So I'm forcing it to do tfrac and dfrac in spots where I needed more or less space respectively. Yeah, there's also backslash vec here to put the arrows over. Yeah, just a lot of math stuff. Oh, come on. There we go. This is actually the latex for the slides. You can see all of the fun outlines over there and the slides, because these are just PDFs. The slides were just a PDF. Let's see. But yeah, it was really cool because since I did the slides with LaTeX and I did the presentations on LaTeX, all my examples I had to like really carefully escape so LaTeX wouldn't interpret them and just put a graph in the middle of the page where I'm supposed to be talking about graphs instead of showing graphs. Um, yeah, this is for code formatting. That's for a package called Minted. Let's see. Yeah, and you can see all the text here. Let's see if I can scroll down. I don't think I ever actually showed you the code for the graphs. So that's down here. Uh, uses the, excuse me, the TIKZ picture environment from PGF plots. And then you can put an axes in here. Uh, we can see here's the labels, the tick marks, so you can control exactly where the tick marks go. Force the width of it to be like a certain width. So in this case, this slide here actually has two columns, like for text, and then I just force the graphs to be the width of each text in each column. Adding a plot here for 0 on a domain here from 0 to 8, and then 100 samples. You can decrease this number of samples and the line will look more chunky, because really all this does is it samples that function at given points through the domain and then just draws lines between the points. So with enough samples, it looks smooth. With too few, it looks pretty bad. But the cool thing is you can actually see the formula right down here. I just put in x squared and it just spat it out like that for me. Here's the piecewise one from the other side. You can see there's actually 3 plots on here. One of which apparently I just took the kinematic like equation and just kind of put it verbatim into the file, which is pretty funny. And then the sine wave here just has sine of degree of x. The deg function does like a conversion between degrees to radians, so it actually shows up properly over here. Yeah, that's really about all I've got for you guys tonight. Sorry, I couldn't really think of a good activity aside from those really terrible assignments I had back in high school where the teacher would give us a Word document. We had to recreate it as fast as we could. That doesn't sound like a very fun competition. So yeah, there you go. Basics of LaTeX. I've been using LaTeX almost exclusively for writing documents for about 3 years now. Since my senior year of high school. Really, it'll do everything Word does. Most of the time better, if a little bit more complex. So I'd say it's worth it to learn it, especially if you're going into academia and you're going to be writing a lot of papers. Definitely learn it then. So yeah, thank you for coming to my huh? Oh yeah. What? Oh yeah. I was gonna say admittedly lackluster presentation, but TED Talk sounds better. We'll go with that. Do you have something else you want to say? Oh yeah. That I used it for? Honestly, probably those physics notes. One other thing that I used it for, which I might be able to dig up here, but it'd take a minute, is my senior year, I took an honors English class in high school, and we had to write a short essay like every week. It was only like a page essays, so it wasn't too bad. But it was like every week, and then at the end we had to compile all of them into one big 3-ring binder book sort of thing. And it was called our senior memory book. Uh, and what I ended up doing was I wrote all those essays in LaTeX. At least after the first like 2 or 3, I started writing them all in LaTeX. And when it got to the end, most people just took all the Word documents and then just printed out like all 30 or so that they had, and then just put them into sleeve protector or page protectors and put them in a 3-ring binder, turned it in, called it a day. I ended up, because I wrote all mine in LaTeX, I actually figured out a way to pull the files into like the one big file. So I just copied the documents, or the LaTeX source files from every essay that I'd written over the year, all like 30 of them, and then made another file that would pull in from those files or pull the actual content of the essays in from those files, and made one big document. Found a LaTeX document class that would typeset it like a book with fancy chapter headings and everything, and resized it down to like half pages, and then I actually bound a book. So I have a leather bound copy of my like senior memory book essays from my senior year of high school sitting on my shelf at home, which was fun. It was a lot of fun, like typesetting it and then binding the book and everything. I think it came out to a little over 100 pages, but it's no way. There's no way that thing sees the light of day ever. What?
Maybe she can, I don't know, get to the Trojan zone and
Sell it through the Trojan Zone? Yeah. I'm gonna, if I ever become a professor here, I'm gonna make people, yeah, here's the textbook. Yeah, it's these essays I wrote in high school. Yeah, this is a computer class. Just disregard that. You have to buy the book. Hmm. But yeah, if any, yes, Josh.
Speaking of program times, are you able to do like newspaper typesetting or something like that using LaTeX? Like, how do you do like column?
Yeah, so that was one of the things I kind of glossed over, but if I go back over to this page, carefully aim the mouse at my physics formula sheet, there's a few different ways to do it. You can explicitly define columns, and then there's also a way to just let it column wherever it wants to column, which is using this multi-calls environment. So I just did multi-calls 3, and then the end of this. Why doesn't the scroll bar scale up with the zoom? That's terrible. The end multi-calls is down there, so I just wrap the whole thing in one big environment. And then that puts each of these into columns as I write them. There's probably a better way to do it for like a specific newspaper if you wanted to do it for a newspaper, especially since then you'll be dealing with weird non-standard paper sizes. But yeah, that's how you do stuff like columns. As for like laying out images, I forgot to put that in too. Huh. You can actually see it on the screen here. Just include graphics and then a path to the image. In this case, the images are just over here. You can see the lens formula sheet or some of the lens stuff, and then the good old right hand rule for electromagnetic fields. That one's a classic. So yeah, there's also, I didn't do it super well here. But when you actually when you include the graphics, there's an option for the width. There's also one for height if you want to specify height, but if you only do one, it'll resize it and keep the aspect ratio nice. You can actually do, I did it a bit better in the presentation over here, I think. Did I not? Did I? I could have sworn I put images in here. I did. Yippee. So we'll go back to this guy running. And you can see up here that I include graphics, and I actually set the width to 0.75 text width, which is one of the other pretty cool things LaTeX lets you do is it actually understands like measurements and stuff. So you can specify a font size of like, 12 point, or depending on the package you're using, if it supports it, you can actually specify a font size of like 4 inches, and it'll just make all your letters 4 inches tall. And if you actually set like a length variable, which text width just gets set automatically, it's just the width of the text box that you're currently in. You can actually multiply that by constants and like add to it. So in this case, I just force the image to be 3/4 of the maximum available width. A better way to do that, there's a fancier way to like actually force the image to like letterbox itself into a box so it all fits in there, because it works fine for our guy in blue there to just be that size. But the overleaf logo is a little bit taller than it is wide, which means if I just clamped the width to the text width, then it would be too tall for the actual box because it'll still be taller than the text box is. So I kind of just took a random stab in the dark at 0.75, and that worked well. That's usually what I do for images. I kind of just take a I generally try and work with text width, but then I'll adjust it based on the aspect ratio. There's probably a better way to do it. But I don't know it off the top of my head. Yeah. Anyone else have anything? Irina?
Color text, like the text color, and also the font family. I don't know.
Yeah, I'm gonna have to remember how to do this. I don't do this very often. I usually just leave everything as the default since that looks better than anything I could clobber together. Um, actually, you know what we're gonna do?
You don't remember.
Yeah, overleaf, text color. We can show off those nice overleaf docs that I was talking about earlier. Zoom in a little bit. Yeah, these are the overleaf docs. Oh yeah, it's through Xcolor. That's right. Yeah, so it gives you a bunch of nice color names, and then you can just where is it? Yeah, you can just backslash color like that.
Like if you just give the RGB.
Yeah, there is a there's a way to do it in here. Uh they just give you a bunch for non just for ease of use. Actually, you know what? I had Xcolor in my in here because Minted for code formatting uses Xcolor. So you can actually, I guess up here, you can define a color like this, and then give it RGB values on a scale of 0 to 1 rather than 0 to 255, because floating point. Yeah, so define color is going to take it's going to take this format for colors, uh, and then take the numbers from here and then define a color with this name. LaTeX is kind of weird in the sense it's not a traditional programming language where it has like variables. There's a lot of like internal stuff that'll keep track of different things. So there are variables in a sense, but they're not like variables like you'd see in a normal programming language. Because like in this case, I think this color is like locked to X color. So like now X color knows there's a color called BG. But like if you found a different coloring package, which might exist, I don't know. There's probably another one out there that uses a different system. It probably wouldn't recognize BG if you defined it with X color. Uh, Similarly, there's a bunch of like lists and stuff that actually has like a counter variable that it attaches to. And you can only nest lists like 7 layers deep without pulling in a special package. Because like yeah, like the way LaTeX, like the way it works internally, it only allows for up to like 7 layers of lists. So there's a lot of kind of weird little things like that. It's very different from any other programming language. It's closer to more of like a macro expansion language, something like the C preprocessor, or why am I blanking on the GNU one? The one used in Automake. What's used in Automake? AutoConf, my bad. M4, that's what it's called. Um, so yeah, it's very different. Uh, and most of the time you don't have to go super deep into it. There's a lot of you can go really, really deep into LaTeX because technically LaTeX is actually a separate system of packages built on top of the original typesetting engine called TeX, where LaTeX was made by Leslie Lamport sometime in the latter half of the 20th century, and TeX was made by Donald Knuth also sometime in the later half of the 20th century, but before LaTeX was made. there's kind of like a causal dependency there. And I don't feel like making any paradoxes. But like these things go like deep, like back to like the 70s. So if you want to go that deep, then you certainly can. 99% of use cases aren't going to require you to do that. So don't get intimidated by that, is what I'm trying to say. When I'm talking about like counters and macro expansion, that's most of the time that's not relevant for everyday use. So yeah, anyone have any other questions? If not, I'll finally let you guys go. So thank you for coming. It was a bit, wasn't the greatest of presentations, but thank you. Thank you. Yes, applaud me.